All right, so we've been covering factoring and factoring different things, but now we're going to actually learn to use factoring for solving things. So first thing, Roman numeral 1 that you want to know is, when do you factor instead of doing something else to solve? How do you know when you're going to use your new factoring skills? So on the left here, we're going to put things you need to factor versus, I'll just call it basic solving. It's the kind where x's go left and numbers go right. So basically, when you are doing normal solving, normal basic solving, you're going to be looking at things with x to the power of 1 and numbers, basically. There might be parentheses, that kind of stuff, or absolute value bars, but the main thing is that the x itself is an x to the power of 1. Your indicator that you're going to need to solve by factoring is if your x is to the power of 2 or 3 or something like that. It will still have numbers in it and parentheses and absolute value bars, but the x will be squared, cubed to some other higher power. The one type of equation that we solve the most often by factoring in Algebra 1 would be the quadratic style of equations, not to be confused with the quadratic formula. A quadratic equation is an equation in the form ax squared plus bx plus c equals 0, which is actually standard form. And that's the one that we're going to be solving the most often in the beginning of this unit, is something in a quadratic form. So lots of ABC factoring is what we're going to be using. All right, so Roman numeral 2, what are the steps? How do we go about doing a solving problem with factoring? All right, step number 1 is you are going to add or subtract all terms to one side of the equal sign. Add or subtract all terms to one side of the equal sign, which means it will be equal to 0. And I find that it's easiest if you go whichever direction makes a positive x squared term. We just do better factoring with the positive x squared term. So if that means you add things left, you add things left. If that means you add things right, you add things right. It just goes a lot faster with the positive x squared term. Okay, now that everything is to one side, you are going to factor equal to 0. And that's the part we've been practicing, is how to factor. Okay, step 3. You're going to use what's called the zero product property. Zero product property to find the solutions. And important is that because you have more than one x, you are going to be finding multiple solutions. You won't just have one solution. And in general, it is one solution per factor. And we'll talk more about that later. So now you have your list of solutions, one solution per factor. Your last step, number 4, is you're going to use set notation for the answer. So, and we've already practiced this, but X is an element of the set containing, and then you list the solutions with commas in between them. And that's how you list multiple solutions, is in set notation. You do not use parentheses, because parentheses mean X and Y, and we're just going to be solving for X. There won't be a Y, so we can't use parentheses. All right, Roman numeral 3. zero product property. Zero product property. All right, this is the property that lets us solve once we've had something in factored form. So here is the rule for zero product property. The rule says if A times B equals 0, then A equals 0, B equals 0, they both equal 0, or neither equals 0. So when we're using this to solve for x, the one that we pick of the possible list is that they're both equal to 0. We find all the possible answers, and then we worry about which ones we're going to keep and which ones we're going to dump at a later time. We don't worry about that when we're first solving. We just get all the answers we possibly can. Okay, and this formula actually makes sense. For example, let's say that if you have d times 6, so some number d times 6 equals 0. The only way that you could multiply a mystery number by a 6 and get a 0 is if that d was a 0. If you've got x times y times z equals 0, if you have 3 things that multiplied to equal 0, at least one of them had to be 0. So we say x equals 0, or y equals 0, or z equals 0, or some combination of those, because that's the only way you can get a 0 when you multiply. It's got to have a 0 in it. And that's why zero product property is very logical. It makes good sense. All right, so we're going to actually now do some solving. So Roman numeral 4, we're going to do some solving. We're going to start easy and then work our way more complicated. So here's example 1. Let's say you factored x minus 1, 2x plus 3 equal to 0. Okay, so using zero product property, x minus 1 is like our a, and it's being multiplied by 2x plus 1, which is our b. And zero product property says if a times b equals 0, then a must be 0 and or b equals 0. That is the only way that they could multiply to give you 0. So what we say is, okay, what if a is 0? So since a is x minus 1, what if x minus 1 equals 0? If that equals 0, what x would have to make that happen? Well, we solve, so you add 1 to the right. X would have to be 1 to make a equal to 0. So that is one possible solution. Same thing with the b. If the b equals 0, what x would make that happen? So what x would make 2x plus 3 equal to 0? So we solve for x, so subtract 3. So 2x equals negative 3. Multiply both sides by a half. You get x equals negative 3 halves. So our solutions, x is an element of the set containing a 1 and a negative 3 halves. Those are our two possible solutions. Now, the ones that we're going to be doing, unless they're a story problem, you can assume that all solutions are valid. When we get into story problems, you'll get like a 6 and a negative 3, and your story problem will be about time, and you can't have negative time. So the negative one gets disregarded, and you keep the positive one because you can't have negative time. So that's the kind of thing where you're going to dump some of your answers because they just don't make sense. But for what we're doing right now, everything is going to work. All right, let's do one that's more fun. Let's say you've got 2x times x plus 7 times 3x minus 6 times x minus 4 equals 0. All right, if I count the number of factors, 1, 2, 3, 4, I have 4 factors. This means I'm going to have 4 solutions. 4 factors, 4 solutions. Sometimes you get duplicate solutions, but if you have 4 factors, you will get 4 solutions. All right, so we're going to set each of these equal to 0. So we're going to set 2x equal to 0, x plus 7 equal to 0, 3x minus 6 equals 0, and x minus 4 equals 0. Okay, so for the 2x equals 0, to get the 2 off the x, we multiply both sides by a half. The 2 cancels out, and we get x equals 0. All right, for the x plus 7, I subtract 7 from both sides, and I get x equals negative 7. Now the 3x minus 6, I'm going to add 6 over to the right. That gives me 3x equals 6. I'm going to multiply both sides by a third to get the 3 off of the x. And so x equals 6 over 3, which is 2. And then the last one, we just add 4 over to the right. X equals 4. So our solutions, and there are 4 of them, are 0, negative 7, 2, and 4. Now, depending on what worksheet that we're doing, sometimes they don't just call them solutions. Sometimes they call them roots. Sometimes they call them zeros. And sometimes they're going to call them X-intercepts. And we'll go through some of those as we learn. But solutions do come with more than one name. All right, one thing I want to show you about this one, which is pretty cool. If you want to know what X-intercepts it is, and I know you don't have graph paper, that's okay. Just draw a little pair of axes. This is just going to be a thumbnail sketch. So in the context of it being X-intercepts, each of those numbers is where it crosses the x-axis. So let's say I have a negative 7 out here. It's going to cross at negative 7. It's going to cross at 0. It's going to cross at 2. And it's going to cross at 4. Each of those solutions are an X-intercept. And then later on, you're going to learn how to do this. But basically, your curve comes down. It crosses at 0, crosses at 2, goes down a little ways, crosses at 4, and then shoots back up. So that's the other thing we're going to be doing with this solving by factoring is we're going to be using it to find graphs of things that you wouldn't have been able to graph otherwise, which is pretty cool. Okay, cautionary tale, for example, 3. Let's say you factored and you got 3 times x plus 1 times x minus 1 equals 0. So following zero product property, you set 3 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. So here's where there's a cautionary tale. Factors have to contain an x, otherwise they're just a numeric scalar. 3 is a numeric scalar. There is no x. So when you set 3 equal to 0, is 3 equal to 0? No, it's not. So 3 is not equal to 0. So that particular factor is a no solution or an NS. So that one you disregard. It doesn't appear in your solution set. You just solve the other 2, which we end up with x is negative 1, add 1, x equals 1. So you just end up with the 2. So your solution is x is an element of the set containing -1 and 1. And this makes sense because the original only has 2 x's. The number of x's in the original is how many solutions you have. It might contain duplicate solutions, but that's how many solutions you should be solving for. Okay, very last one. We're not actually going to finish it. I just want to make sure that we did one. Let's say you've got x squared minus 4x equals 5. This whole process depends on the equation equaling 0. So on this one, before you can start to factor, you got to make it equal to 0. So we have to subtract the 5 over to the left. That gives us x squared minus 4x minus 5 equals 0. Now you can actually factor and then solve. But you have to get it equal to 0 or we can't use zero product property to solve. So I wanted to put one on just so you can see sometimes you have to add or subtract the terms to one side. All right, that is the end of the notes. Are there any questions? Yeah.